Good morning, everybody. So today we'll be doing the last few parts of the Newton's laws. We are gonna be doing the free body diagram on an inclined plane. Okay. So since you know the weight is always a downward force, what you can just do, you will just start by doing the weight, which is a downward force like this. Then you see weight, ne? But right now this is an inclined plane. This is not a horizontal surface, so your normal force will not be the one looking upward, ne? So I want you to check something. This is an example of an inclined plane surface. Check this one. This is an example of an inclined plane surface. So I want you to check something, and I want to show you some differences there. So since you know what the normal force acts on the surface in contact with and whatever, I want to show something. Check. I know what my weight is a downward force on it, so I already did that. So let's do the free body diagram for the 2 kg block. Okay, so my normal force is always perpendicular to the surface. So for it to be perpendicular, I have to make it like this. Let me do it here. I have to make it like this to go that side. Alright, since 2 kg is not the one, let me just do it here on the 1 kg block so that you can understand what I'm talking about. It's not gonna be straight, it's gonna be something like this. You see, it is not straight, it's gonna be something like this, whereby I know what it makes my perpendicular sign here, and then my weight is going where? Down. You understand? Just like as I showed you yesterday with the introduction of free body diagram. So my normal force is not gonna go straight, but it's gonna go perpendicular to the surface. So you will just use a ruler and then you show what your normal force is perpendicular to the surface. So for the 1 kg we can do something like this and say Fn. You see, that's how we must do it. Then it will be perpendicular to the surface. Okay, now the problem here is since I have my inclined plane here and I have a force applied going that way, you can simply do this and then you can say F applied, because here there is a force applied. Okay? You understand? So since we all know what every force applied has the frictional force, so it's obvious what I will have to increase my dot here and do my frictional force with the kinetic friction. And then there is a string here, as they told us what they are they tell us no, they didn't, but what I can see here, it is the string. So it means what this one is the what is the tension. You see? So let's do the one for the 2 kg block. 2 kg. It's not that difficult. The difference is that the weight is always down, normal force is just like that, and then you take the force applied as they are. So the weight is there, the normal force is like this. Every inclined plane normal force is like this. It's not straight, and so here we have the string, which is the what, the tension, and you understand. But the two that's what the kinetic frictional force between 2 kg and the block is 8 newtons. So which means what in this 2 kg there is a kinetic friction. So we are gonna do another dot here, which is Fk. Don't forget to go to friction opposes motion. So this 1 kg pulls 2 kg to that side. So this 2 kg wants to go there, but there is a friction that is pulling it down that side. Yeah? So this is how we do a free body diagram. Your normal force always look like this, and the weight goes down and like that. Let me show you something. Right now we have a different scenario whereby our inclined plane is like this. So when it is like that, you simply do your weight. And if it is the 4 kg block, you just say 4 kg, weight down. Oh, sorry. Weight, my weight is where? Downward. Mara, my inclined plane is like this, ne? Which means with my normal force is gonna look where? That side. And do what? Fn. It must be perpendicular to the surface, don't forget that. And then I have the string here, so I will just make it like this, which is tension. You see? So it is not that difficult, because these are just that difference. This one is looking, the normal force here, it is looking that side, then the tension, it is looking this side. The normal force that side is looking that side, and right now the tension is looking there. So those are just the two differences. You see, this is the horizontal surface, normal force up, Fg down, there is a friction, and this is the tension. This one, normal force, it is like this, then weight goes down. You see, tension, you're done. And I want to show you something. The first question, or this doesn't have a mark allocation. Okay, check this one. It is saying draw the free body diagram for all the forces acting on 8 kg. How many marks? 5 kg. So I already know what I have the two forces, normal force and the weight, then force applied, which is 3, and there is a kinetic friction over here since there's a force applied, so it will be 4 and 5. The string, the frictional force, the normal force, the weight, and the force applied. 1, 2, 3, 4, 5. They make up 5 marks. So if they say draw the free body diagram and they say 3 marks, just know what you must do: 3 lines. If they say free body diagram and but 5 marks, you must show them 5 marks. Another thing that you can do, besides doing the, what do you call, the maybe if you forgot if you maybe you don't know if you must include the frictional force, you can do this. You can simply say my FG here, my weight here, then you say your normal force there, and then you can do this and say FG parallel, because this also a force that is acting on an object. But I told you yesterday, FG perpendicular and FG perpendicular are the abstract forces. You cannot see them, but you have to know the general information. So these are the abstract forces. So another thing that you can do there, you can even say, when you go there, you will say you can even say FG, or there's a force applied, you can say force applied, and then here what you can do, you can say FK, since there's FK for the 2 kg block, and then you can even say again here FG perpendicular, because FG perpendicular, it is acting perpendicular to the weight, because these two are the components of the weight. So that is another way of representing your free body diagram for the inclined plane. Normal force is like this, weight is downward, then you take everything as it is. Always use a rule. So another thing that I want to show you, let's just say they say draw a free body diagram for the hanging block. As you can see, it is 5 kg. So when it is hanging like this, when it is 5 kg, it is normally 2 marks. So I know what it is the string. So I'm just gonna say my dot and do my what? String. I will say T. Normal force is not there on the string, on a hanging block. There is no normal force on a hanging block. That's what you must know. And then, since it is hanging, there is a force of gravity, obvious, which is acting downward. Then you say FG. You say FG. You understand? So please, there is no normal force for a hanging block. There is no normal force for a hanging block. When the object is hanging, you have the weight and the tension, since there is a string. Yeah, I guess that's all that I just had to tell you today. And I'm done with the free body diagrams, and the case is closed. Okay, so let me tell you some few things. So this is what you just have to know. You just have to know that the normal force is perpendicular and the weight is always a downward force. There is no normal force for the hanging blocks, and the hanging blocks have the tension and the frictional force, unless if there is another, maybe there is a friction on the hanging block. That's when you can include it. You see. So thanks guys, I'm done.